Good morning, Matt. Good to see you.
Good morning, Michael. I'm glad we see our good friend, the parabola, up on the screen. Take us through what we're doing with it.
Well, you're right. It's the parabola again. So we've got this curve. And remember, what we're trying to do is take a curve that might be expressed here as a function y is equal to f of x. And then we want to approximate with a line. So here's an equation of a line. Does that look familiar to you?
Oh, yes, that's what we have been discussing. And y minus y naught we commonly know is the rise, and x minus x naught is the run. And the ratio of the two is the slope.
And we call that m, right?
Yep, that's ready to go.
So in my little curve, I actually have the line to approximate. And if I move the point on the curve to this point, I see m is equal to 2, so my slope is 2. Does that make sense to you?
Sure, because if you look carefully at the figure, the run is 1 and the rise is 2. So 2 over 1, 2, that's the slope.
Exactly.
And it changes as you go up the curve.
Exactly, it changes. So if I keep moving this point, we notice the slope gets higher and higher. Here's the slope of 3, slope of 4, slope of 5, and it just keeps on going like that. Let me get this out of our way. Do you remember the equation for the parabola?
Y equals x squared.
Well, let me put that up for you. Okay.
Great.
And we're going to do a calculation now where we try to approximate this y is equal to x squared with a line.
Let's pick 3 as a nice number.
Yeah, rather than doing the general question, let's do x naught equal to 3. So what I'll do is we'll start off by saying, you know what we want to do is take our function and approximate it with a slope. And I'm going to replace that x naught with a 3. So instead of x squared minus x naught squared, I've got x squared minus 3 squared.
And
What do you notice about that?
I noticed that that's the difference of squares factoring where the cross terms cancel out.
Exactly. So we've got a nice little formula to, this is the exact value of the function at x minus the function at 3. It's x plus 3 times x minus 3. Now, we want this to be approximated by a line. And we look at this and we say, hey, this second term kind of looks like the term in the line, except the part in the front doesn't look like a term in the line. So how could we maybe fix this so that it looks more like a constant times x minus 3?
Well, we have to substitute for x. And a reasonable value is we're looking at near 3. So let's just put x plus 3 equal to 6.
Okay, that's a great idea. So basically what we're doing is we're replacing the x with a 3. You get 3 plus 3 is 6. Now, do you notice this little squiggly equal sign?
Yeah, approximately equal to, because we're approximating the true difference with a line.
And that's what we see in the picture. We see the straight line is not exactly the curve, but it's approximately the curve.
It's pretty good, and you can quite well see how important it is to make that jump. But the question will arise is, what happens when x equals 3?
So this is exactly the x equal to 3, and we see the slope now is this first factor, 6.
So but at x equals 3, we're not really sitting at 3. We're sitting at a neighborhood of 3. And that's why you have the approximate sign.
Exactly. Should we try another point?
Sure, try another point.
Should I try 4 or 5 or?
Take it way up to the top as close as you can get to the top.
I can get all the way up to, oh, look there, m is equal to 6. And we see our value for x was 3. So 3 times 2 is 6.
Fantastic. Where do we go from here?
I think we should try a general point. So instead of 3, let's take x naught. X naught could be anything. It could be 1, 2, 3, a million.
Sure, let's go and see what it looks like.
Okay, so what I'll do first is I'll hide our calculations with 3. And now we'll look at a general x naught. So we take our quadratic right there and subtract it, evaluate it at a general x naught. Does that still factor?
It still is the same. It's the same pattern. You just replace 3 by x naught to give it a general setting.
Now again, the second part looks like a line, except our slope, the m term, Doesn't look constant. So what should we do here?
Same as before, we'll say you're in the neighborhood of x naught. So the first term, the x plus x naught, we'll say, well, an approximation is to put x equal to x naught.
And so x naught plus x naught is?
2x naught, which is the slope.
So let's put this down. And you're right, we've got a formula for the slope, 2x naught.
So now that we've illustrated this, maybe we could go in a more general setting like x cubed or x to the fourth. What do you think?
I think that's a great idea. Why don't we do that next time?